Okay, in the next series of videos, we're going to be talking about transformations of graphs. And before we do that, it's very, very important that you study your parent functions, that you know what your parent functions are. Parent functions, y equals x squared, y equals the absolute value of x, y equals the square root of x. These are a few. These are only 4 of maybe 6, maybe 8 that we're going to talk about. Y equals x. When you put a negative 10 in, you're going to get a negative 10 out. So these are going up by 2's. Okay. When you put a negative 8 in, you get a negative 8 out, negative 6, negative 6, negative 5, negative 4, negative 4, negative 2, negative 2, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 6, 6, 8, 8, 10, 10. So your graph for y equals x is that of a straight line. It's important to be able to recognize that that's a linear function. It's called a linear function. Okay, y equals x squared. When we put a negative 3 in, we're going to get a 9 out. If I put a negative 4 in, I get 16 out, which is off the grid. If I put negative 2 in, I get 4 out. Negative 1, 1, 0, 0, 1, 1, 2, 4, 3, 9. So if you need to make a chart, a table, you're going to want to study this so that you can know exactly what this graph looks like and what it's called. This one's called a quadratic function. This next one is your absolute value function. When you put a negative 10 in, you're going to get a positive 10 out. When you put a negative 8 in, you're going to get a positive 8 out. Negative 6, positive 6, negative 4, positive 4, negative 2, positive 2, 0, 0, 2, 2, 4, 4, 6, 6, 8, 8, 10, 10. These are two straight lines that meet at the origin. We could make this a piecewise function, but we'd probably be talking more in this video than we need to be, so I'm just going to leave it at that. It's an absolute value function. That's the name of it. We've got y equals the square root of x. Y equals the square root of x. If I put negative 10 in, the square root of a negative is imaginary, and that doesn't have any place on the x, y grid. Therefore, our first value that we can put in is a 0. And when we put a 0 in for x, the square root of 0 is 0. We get a 0 out. When we put a 1 in for x, the square root of 1 is 1. So put a 1 in, we get a 1 out. The next value, that's not a 1, that's a 2. 1, 1. This is 2, 4, 6, 8, 10. The next input that we can put in and get a lattice point out, I'm going to talk about lattice points. Lattice point is when you have an ordered pair with integer coordinates. Those are lattice points. If I put 2 in, the square root of 2 is not an integer. The square root of 2 is about 1.3-ish. The next value that I can put in would be a 4 to get a lattice point out. If I put a 4 in, the square root of 4 is 2. What's the next value that I can put in and get an integer out? If you're thinking 9, you are correct. You put a 9 in and you get a 3 out. And then the next one would be a 16 because you would get a 4 out. And then the next one would be 25 because you'd get a 5 out. And this is a curve that looks just like that. And this is called the square root function. Square root function. These are all called functions. Linear function, absolute value function, quadratic function, square root function. Okay, those are 4 of them. This you'd want to study. You should be able to graph each one of these graphs in less than 30 seconds. So a timed quiz, you should be able to graph y equals x. Just go boom, 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 boom. Put all your points there. Use a straight edge. Graph your line. Absolute value, same thing. Put all your points there. Use a straight edge. Those would probably take the most time because you're using straight edges. Then you'd have your quadratic function. That just needs a little bit of sketching here to get the curve down pat. But this has only 2, 4, 6, 7 lattice points. Square root function only has 4 lattice points. Boom, 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 boom. Draw the curve. Move to the next problem. So what would the next one be? Another good one is y equals x cubed. That's called the cubic function. When I put a -3 in, I get -27 out, which is way off the grid. So I'm going to put a -2 in. When I put -2 in, I get -8 out. -2 cubed is -8. When I put a -1 in, I get -1 out. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. This is a polynomial function whose special name is a cubic function. Now, related to that cubic function is the cubed root of x. This is the cubed root function. And this one, we have to go backwards. We have to think, okay, what would I put in? What value can I put in for x that's a cube? Well, -8 is a cube. It's a cube of -2. So you put a -8 in and you get -2 out. The next cube would be -1. Cubed root of -1 is -1. Then, of course, 0. Cubed root of 0 is 0. Cubed root of 1 is 1. And then the cubed root of 8 is 2. What's related about this function is you could see the rotated turn between the cubic and the cubed root function. It's pretty nifty. Okay, another important one is the rational function. This is a rational function. Now, x can never be 0. We've talked about that a zillion times at this point. X can never be 0, so I'm going to highlight x equals 0, which is a vertical. X is 0 along any point on that line. So we're just going to highlight that entire vertical axis in yellow because the graph cannot pass through that yellow line. Another thing is that our outputs will never be 0. Since the numerator is a 1, our outputs are never going to be 0. So I'm going to highlight our outputs being 0 as well. So we know that our graph is not going to cross those two lines, those two highlighted lines. And those two highlighted lines are called asymptotes. We'll talk about those in a later lesson. But for now, we're just going to draw them and know that our graph can't cross those highlighted lines. Now, if I put a -10 in for x, I'm going to get -1/10 out, which is about that. If I put a -8 in, I get -1/8 in, which is about that, which you can't really tell a difference. -6 is like that, and you can't really tell a difference. And -4 is like that, and you can't really tell a difference. And -2, -1/2, -2, -1/2 is like that, and you can't really tell a difference. But then you put -1 in, and you get -1 out. There we go. And then you put -1/2 in and you get -2 out. And you put -1/3 in and you get -3 out. You put -1/4 in, you get -4 out. And you can try all these graphs. So what happens is that your graph, let me draw this part of the graph in red. I'm going to make it a dark red line. There we go. Look, see? So that's part of our graph. That's for all of our negative inputs. Then when we put positive inputs in, we hop over x equals 0 and we put maybe what? Put in 1/10, you're going to get a 10 out. 1 divided by 1/10 is 10. And you put in 1/2 and you're going to get a 2 out. And you put in a 1 and you get a 1 out. And you put in a 2 and you get 1/2 out. And you put in a 3 and you get 1/3 out. And you put a 4 and you get 1/4 out. So you can see that you've got this graph that is symmetric about the origin. So it's got that symmetry going on. So 1 over x is this graph right here. Knowing this graph is really, really important. Okay. And what's another good graph? I'm thinking. Another good graph. Another good graph would be y equals the square root of, let's say 16. 16 minus x squared. 16 minus x squared is going to be a semicircle with a radius of 4. So -4, +4, +4. And it's a semicircle whose center is going to be at 0, 0, but who's going to have a radius of 4. If I had y equals the square root of 25 minus x squared, that radius would be 5. So you'd go center at 0, 0, and you'd go out 5. And if I wanted a radius of 6, it would be 36 minus x squared. And so on and so forth. So this is a semicircle with a radius semicircle with a radius equal to 4. Okay, so we're ready to talk about translations and reflections. This is review. If I have a function and I add c outside the function, that's going to translate that parent function up c units. And if I subtract c outside of that parent function, it's going to translate the graph down c units. And if I add inside the function, adding is going to result in a left move, while subtracting inside the function is going to result in a right move. A negative on the outside of the function is a reflect in the x-axis, and a negative on the inside of the function is a reflect in the y-axis. Now in the next video, we're going to describe this translation, and then we are going to sketch it.